Hey you guys, I just had a thought here. I'm sitting there looking at this question for a math student, and the question was, I'm not sure if you can see this, see if you can read that. The question was, calculate the radius of a cone if the slant height is 12 centimeters and the lateral surface area is 158.34 centimeters squared. So I was sitting there thinking, yikes. Hopefully the students are going to draw it out on paper. But then even if you drew it, I was like, would you know where to start or what these different words mean and how do you figure out all this stuff about a cone? So I thought, you know what, let's go back to our trusty circle and let's make our own cone. So say, for example, see if this makes sense to you. I don't know if you watched the previous video, but if they're talking about the slant height for a cone. So let's get started. Here's our circle. And I'm just going to fold it in half. And in half again, just so we can find the middle of our circle. Okay, so where they cross is the middle of the circle, and I wanted that because to create a cone, you can start with the circle. Now I'm just going to cut up cut the radius, because remember the radius is from the edge of the circle to the center. So there, I cut the radius, and with this circle now, to create a cone, all I do is I overlap it as much as I want. Overlap a little bit. You have a short, wide cone, overlap a lot, you get like a tall, narrow cone. And do you notice this? So if I tell you that, first of all, in the question, how about we look at that? The question says the slant height is 12. So if you're looking at a cone, the slant height is the distance from the bottom to the top of the cone along the slanted part. So could you agree with me? It's from bottom to top. That's along the slanted part. Well, check this out. If I open up the cone, that same distance from the bottom to the peak, do you notice anything special about that? It goes from the edge of the circle to the center, because that would be the top of the cone. Huh, interesting. It's the radius. So I'm going to write, the question said the slant height was 12. So on my circle, I'm going to write here, radius equals 12 centimeters, since that's the same as the slant height. So that's nice, that's nice. It takes the cone back to our good old regular circle. Oh gosh, okay. The slant height is 12, which is the same as the radius if you open it up. And they also say the lateral surface area is 158. All right, so the lateral surface area. So we don't know how much they've overlapped their cone, but what lateral surface area means, lateral is like side. So it's the surface area of the side of the cone. So let's just say it overlapped to here. I'm going to draw a line. If it overlapped to there, if I open up my circle, and I like to do this too before I open up. I put a little check mark. This is the good side here. This is the good side here. Anything underneath this circle, or underneath where the cone overlaps, I'll put an X, because that would be cut off if that's where our cone was. So if I open it up, if you can see that full circle, I'll draw it a little darker. If I cut this out, this part would be gone. All the way to here. Okay, so this, what you see, this weird shape there, that would be the surface area, the lateral surface area of a cone. So again, fold it up, and you would see that these sides come together to create our cone. Sorry, it's tough to do it while trying to record here. So there's our cone. Open it up. We want to find the surface area of this part of the circle. So here's where it's kind of cool, where the circle and the cone information overlap. I mean, you could probably find this using some formula you've memorized and hopefully get it right, but maybe you don't totally understand it. So instead of doing that, if you look at the circle, if you were asked to find out the complete area of this circle, you could maybe remember a simpler formula. If you remember the area of a circle, area equals pi r squared. So since area is pi r squared, we already know the radius is 12 because that's the slant height. So then we can say, okay, so the area is going to be pi times 12 squared. 12 times 12 is 144. 144 times pi, you could work that out on your calculator, and it happens to be 452.4 would be the area, centimeters squared. So there we go, 452.4 centimeters squared of this entire circle. But we know when we make a cone, it doesn't take the entire circle because there's some overlap that gets cut off. So what we need to figure out is okay, how much was cut off? Well, if nothing was cut off, it would be 552.4 since the radius was 12. The question, and here's where I hope you're writing things on paper. If we go back to the original question, they're telling us the lateral surface area was only 158.34. So we know a lot got cut off. How much? Well, let's figure out what percent got cut off. If you now take the total would have been 452.4. What percent is 158.34 of the total? So you could work that out. You could go 158.34 divided by the entire circle, 452.4. And if you divide that out, you end up finding, oh, hey, it's 0.35. So really, the cone is 35% of that original circle. And this is the cool part. So since the cone is 35%, they want us to calculate the radius of the cone. Well, if you look at the cone, the radius of the cone would be the distance from the center to the edge of the bottom circular part. And do you notice how that changes? If we had only a tiny bit cut off, the radius of our cone would be pretty huge. If we cut a lot off, so make it a tall, thin cone, then you look, the circle here, the bottom of the cone got smaller, so the radius is smaller. So the amount that we cut off is directly related to the size of the radius. We cut off more, so the surface area, the lateral surface area of the cone is smaller, the radius is smaller. The lateral surface area of a cone gets bigger, then that means the radius of the cone gets bigger, and that's the radius of the bottom circle part of the cone. And it just so happens it gets bigger and smaller by the same percentage. So we figured out, well, because the surface area of this lateral cone was 158.34, that means it was 0.35% less than the full circle. So, since our radius of the full circle is 12, that means the radius of the cone is going to be 35% of the 12. So then you can say, okay, well, take 12 if you can read that, times 0.35, and that will give you the radius of the cone. Hope that helps. But you know what? To really understand this, you need to experiment with your own cone. I'd say make a real cone, measure out what the actual radius is, and play with it. See how, if you have the size of the cone change, so the actual lateral surface area, the radius of the cone itself, not the radius of the circle, but the radius of the cone, the bottom part here, how that changes. Play around with it. Let me know how it goes.